All right, here we're going to look at the concept of the zero product property. Now, the last two videos for examples 1 and 2 have basically just been kind of leading to the zero product property and how we're going to use it to solve equations. So the zero product property states that if a product of real number factors is 0, then at least one of those factors must be 0. In practice, kind of what does that look like? In the case of two factors, basically if you have a times b, sometimes people like to put a little multiplication sign in there. A times b equals 0. Then either a has to be 0, b has to be 0, or both of them can be 0. And to use the zero product property, this is important. You must rewrite the equation so that is an expression equal to 0. All right, then you can factor it, and then you can solve it. So if I look at example A, where we're trying to solve this equation, the equation is not equal to 0. So what I want to do is I want to subtract 42 from each side. And now I have an equation where the right side is equal to 0. All right, we can't use the zero product property unless the equation has one side equal to 0. From here, I'm then going to use my factor sum chart. So factors of negative 42 that have a sum of a positive 1. So remember there is a 1 here. So we're looking for factors of negative 42 that have a sum of 1. So listing the factors, we have 1 and 42, 2 and 21, 3 and 14. Yeah, and again, as you get better at this, you might start to learn which numbers work a little bit better than others. And we have 6 and 7. So 6 and 7, we know we have a factor of negative 42, so that means one of my numbers has to be negative. And if I make the 6 negative, when I add those up, I do get the sum of 1, which I'm looking for. So the factored form here would be x minus 6 times x plus 7 will be set equal to 0. Now, again, the factor sum chart, as you get better, you can start kind of skipping steps. You might be able to jump right to the factors that you know are going to work. So I've kind of left part of it blank because I knew obviously negative 1 and 42 is not going to give me a sum of 1. Now, from here, this is the step where we can start to use the zero product property. The zero product property is telling us that if we have two terms, all right, let's call these A and B, and they're equal to 0, then either A is equal to 0 or B is equal to 0 or both. So what I can do now is I can take the x minus 6 and set it equal to 0, and the x plus 7 and set that equal to 0. So I'm taking each piece, each factor, and setting them equal to 0. Now I can solve these as I would a normal equation. And I'm going to see that my zeros are x equals 6 and x equals negative 7. Now, if I was to graph this, these would be my x-intercepts, where my graph, my parabola in this case, will cross the x-axis. So again, put the equation, set it equal to 0. Then you're going to factor it, in this case using the factor sum. And then once you have that, you're going to take each of your pieces, each of your factors, and set them equal to 0. In part B, we have 2x squared equals negative 9x plus 5. Now, I could move the 2x squared to the right, and that would be one simple process, but I generally like to keep my a value, whatever term's in front of the x squared, positive. So I'm actually going to move the 9x and the 5 over. So I wind up with 2x squared plus 9x minus 5 is equal to 0. All right, again, the reason I'm doing that is I do like to try and keep my a value positive. This one's a little bit more drawn out because we have to use the AC method. So I'm going to do 2 times negative 5 is equal to negative 10. So I need factors of negative 10 that have a sum of positive 9. Be careful in this case. All right, so that 9 is coming from here, and then my negative 10 is from these two. So again, factors of negative 10, we have potential of 1 and 10, 2 and 5. one of them is going to have to be negative. If I add up negative 1 and 10, I get 9, which is what I'm looking for, so that wasn't too bad. So we'll rewrite this. Make sure you're still using that equation, setting it equal to 0. So these become my new factors. And now I factor by grouping. So I get x times 2x minus 1. I'm going to factor out a 5 from the second group. So again, I get 2x minus 1. Again, if the AC method, I'm not going into great detail with it here. If you have trouble with the AC method, remember that our videos specifically for the AC method, so you can go watch those, and that'll help you with the factoring process. Now that we've factored this expression, it's set equal to 0, we can go back to the zero product property, which tells us that we can now take each of these pieces, each of our factors, and set them equal to 0. So 2x minus 1 is equal to 0, and x plus 5 is equal to 0. So now I would add 1, divide by 2, so x would be 1/2, so that is one of my zeros. And then here I'm going to subtract 5, so x would be equal to negative 5, and that would be my other 0. Now, as you can see, we're able to find the zeros without having a graph for them. If you were to graph these quadratic expressions, you would see the graph and you would find that the x-intercepts are the answers that we have boxed in here. But the zero product property is incredibly important here, understanding that two products, when you multiply them, or sorry, the product being the result, if you have two pieces, in this case A and B, when you multiply them, one or both of them must be 0. So go through those steps, and you should be okay with this. Just be careful. The problem has to be set equal to 0. One of the most common mistakes I'll see is either the pieces not being moved over correctly, and the signs kind of getting mixed up, or students just forgetting to set it equal to 0. So make sure that that's not you, and you do set the equation equal to 0.